Hello all, welcome to FOSDEM. Welcome to an Encrypted Matrix talk by Matthew Hodgson. So Matthew is a technical co-founder of Matrix.org. Matrix is a VoIP and IP messaging solution. Matthew has been building IP solutions for around 11 years. Please welcome him to the stage, and we can start the talk now.
Thank you, Pravi. Can everybody hear me? Whoa, fantastic. So welcome to the land of Matrix, everybody. I'm going to be talking about the epic that we've had over the last few years to add end-to-end encryption throughout all of Matrix. But before I get into that, I probably need to tell some of you what Matrix is, or what is the Matrix, if you prefer. So just quick show of hands, who already knows what Matrix is? Wow, that's really, really scary. So that's probably over half of the people here. So I apologize that, especially if you came to the talk this morning on reputation, that there's going to be a little bit of overlap whilst I try to bring the other 40% up to speed. I'll try to do it quickly. And also, if anybody has any questions whilst I'm talking, I'm quite happy to be interrupted. So please, wave your hands around if you want to get clarification, or if I'm talking too fast, or in the wrong language, or you can't understand what I'm saying. So, let's get on. What is Matrix? Well, we're a non-profit open source project, obviously, and we're unusual in that we're providing an open standard here for defragmenting communication. So in practice, this means that we're basically creating a global encrypted communication meta-network, and we call it a meta-network because apparently the word internetwork has already been taken, that bridges all of the existing silos together. So by silos here, we're talking about all of the islands which don't interoperate today. So that could be IRC interoperating with XMPP, it could be Slack, or Gitter, or Telegram, or WhatsApp, or Facebook Messenger, and, well, I mean, I'm sure I'm preaching to the choir here, but everybody must be suffering due to the way in which all of the different communities for just communication online are fragmented these days. There is no equivalent of email for instant messaging or VoIP or even IoT kind of data. And that is what we're trying to fix with Matrix. And the whole point is to liberate the communication here so that it is controlled by us, the users. You should not be locked into a walled garden or a silo which is controlled by any single entity for something as basic as your right to communicate. So, in terms of the kind of silos we're talking about, we have things like IRC, or Gitter, and Slack, and I'm sure especially in the open source community, we're very familiar with the fact that you have a perfectly good IRC channel that lasts for 20 years, and then Slack comes along, and half the people want to go to Slack, and then half the people are on Telegram, and then people start using Discord, and the whole integrity of the thing breaks down. Well, the point of Matrix is to come in, basically, as the lowest common denominator fabric to connect them together. So you have the bridges here that go and connect, I know, IRC through into the wider decentralized Matrix network, or for that matter, Gitter or Slack or any of these guys. Even an application like GitHub, you can go and bridge into the wider scheme of things via a bot or integration that allows you to start talking to issues on GitHub or filing whatever issue it might happen to be as if it were a chat system. And inside Matrix, we have this full mesh of servers which participate in the conversation. And the really sexy, fun thing about Matrix is that the conversation history is replicated over all those servers. So this is like Git, but for communication. There is no single chat server for any of these conversations. So if some chap on IRC is talking on Freenode and it's bridged into Matrix, talking to somebody natively in Matrix, like this guy, or somebody in Slack, then that server, and that server will all have a copy of the same conversation. And this is incredibly powerful because it means that if any of those servers go down, the conversation lives on. So literally tomorrow, Matrix.org with its server could go down, but because a lot of the rooms are replicated over hundreds of other participating servers, the room lives on. And we think this is pretty cool because it's basically impossible to communicate on Matrix without breaking open a walled garden. The actual act of going and communicating with anybody elsewhere gives them equal ownership of that communication. It is impossible to hoard control. So no single party owns your conversations, and also the conversations are equally owned by everybody who's participating. What can you use with this for? Well, classic use cases are group chat, WebRTC signaling for VoIP, because I'm sure many are familiar that WebRTC doesn't have a standard signaling layer. Bridging any kind of communication silo together. It's also kind of cool because in the end it's really an open object database for any kind of real-time data. So you can use it as a big open decentralized fabric where people can do puts of data and somewhere else people can get them, and that can be any data. We've done MIDI over Matrix, we've done drone control, we've put car telemetry in. And really, in the end, yeah, it's basically a pub subsystem, but for real-time persistent data. Some people in the audience, how many people are thinking, why are you reinventing XMPP? 1, 2, 3, 4, 5, 7, okay, about 10% of the audience are having the same reaction as this poor cat. Now, from our perspective, we're not. Really, we're not. I mean, it's very different to XMPP, and it kind of goes on a philosophical and a technical angle. On the philosophical angle, the actual spec and the governance model of the project is completely different. There is one Matrix spec. It has one version. There are no zaps, no extensions. Of course, you can extend it yourself and you can experiment with it, but the actual thing that people have to implement to be compatible is today Matrix 0.2. And if you don't implement it, you're not talking Matrix. And whilst it seems like a bit of a kind of legal point, it actually changes the philosophy enormously of the project. So you have one big spec with all the features in it. Some of them are optional for different profiles, but in general, for the classic ones, you have your instant messaging, your VoIP, your read receipts, your notifications, and all the stuff that you need to communicate. Also, the primitives are completely different. So conversation history is the first-class citizen here. We're not passing a message between Alice and Bob. We're synchronizing Alice's chat history for this room with a server which then synchronizes it with all the other users in that room. And that's just a huge fundamental difference, that you're literally synchronizing eventually consistent history around the place. Also, we have end-to-end encryption, albeit still in beta, as a first-class citizen throughout the whole thing, because if you are replicating data everywhere, you obviously want to encrypt it so that the sysadmins aren't reading all your messages. And we're using HTTP and JSON, but if people are thinking, wow, this is just XMPP with JSON and HTTP, you're missing the point completely, because it's not just swapping XML for JSON at all. As I said, this is basically an open database. Think of it like Cassandra, where anybody can spin up a node anywhere in the world. That's the kind of model that we're going after here. And obviously, finally, we've got a big focus on bridging and defragmenting. Now, that's why the thing's called Matrix, because it is matrixing together all of the different communities out there which otherwise can't talk to one another. Architecturally, we kind of already touched on this. You've got some servers in the middle which store the messages. You have clients that connect to them. You have application services which do the fun stuff, bridging and other things. Oh, I've got a question. Quick question. Just yell at me.
You mentioned that all the messages are replicated between the nodes and stuff.
Oh, it's okay. So it's asking all the messages get replicated between the servers.
Yeah, you were mentioning that the messages are replicated within the servers. I know that it's encrypted end-to-end and stuff. Is the message on each server encrypted on the server itself? And is there, if it is, it's fine. If it's not, is there forced secrecy?
Okay, so there's a question about end-to-end, and basically all of the rest of the talk is about end-to-end encryption, so we'll get to it in excruciating detail. But the quick answer is that in order to be end-to-end, by definition, it has to be encrypted on the clients, not the servers. At the moment, it isn't turned on by default because we're still in beta, but when it is, it will be there. And then the actual data stored on the servers is obviously encrypted by the end-to-end.
Okay, yeah, I was just worried that if one of the nodes get compromised, then all the messages can be read.
No. So, well, actually, good question. So forward secrecy is the big, interesting bit of what we've done with the encryption in Matrix, in that we make it customizable per room. So if you were using Signal and you're optimizing for nothing other than privacy, the idea of being able to replay history on new devices would be a disaster, because what if that device was owned by some nasty person? Whereas if you want to configure a room like that in Matrix, you can. But then some rooms aren't quite that tinfoil hat level of security, and you want to be able to add a new device into the room. And so in that instance, we allow people to select chunks of history that can be replayed. So it's a kind of deliberate compromise to PFS. in exchange for usability. So, Matrix ecosystem as a whole, very quickly. The main deliverable is this boy here, the Matrix spec, which is a RFC-style doc that describes all of the APIs and all of the actual functionality. Then we have Synapse, which is our original Python home server, which has been out there for 2 years now. It was very much a proof of concept. It has some major shortcomings, although nowadays, as of yesterday particularly, it now has never been a better time to install a Synapse, which is on 0.19. It's written in Python and twisted. Memory usage has got a lot better. CPU usage has got a lot better. And it's kind of the one home server that works is usable in reality right now. Dendrite is our next generation one, written in Go, that uses a really interesting append-only log architecture. So whilst Synapse is completely centralized, or is a kind of monolithic server of a big bunch of Python, Dendrite has got a completely horizontally scalable architecture where you keep on firing up more components, and they all talk over a big Kafka-style event bus to scale up. We've got basically the first messages going through it in the last couple of days, so it's very, very early, but that's where the future lies. Then you have bridges that connect through to IRC and Slack and everything else, and bots and integrations and all that good stuff. And then the orange stuff here is stuff from the wider community. The blue stuff is all provided by us, the Matrix.org team. The orange stuff is provided by you, the wider community, and there are lots of different servers and services there. There's Rumor, which is a very cool Rust project to go and create a Matrix home server, and there are lots of bridges. Over half of the bridges now come from the community. And up here we have clients. So here are the community clients, and we have everything from command line to sort of native to web-based ones. Then we provide 3 stacks of JavaScript, iOS, and Android on the client side. And you have the React SDK, which provides kind of reusable React UI components. You have the HTTP wrapper, which actually exposes this guy as sensible JavaScript bindings. And then on top, you have the actual applications. And you have the ugly console apps, which are kind of proof of concept wrappers around the UI components. And then you have this guy, Riot, which is a kind of flagship app that we've built in order to make sure that Matrix has a really, really good app that people can use on a daily basis and can kind of bootstrap the whole ecosystem. So what do you get? Very quickly, obviously, conversation history. You get a timeline data structure, key value stores, group messaging, end-to-end crypto, obviously, VoIP signaling for WebRTC, push notifications, server-side search, read receipts, typing notifs, presence, synchronized read state and unread counts. We gather very, very crap decentralized content repository where you do an HTTP hit to your server and it fans out to the others via HTTP. We're looking at replacing that with IPFS. And finally, you can attach arbitrary account data for users, both per user and per room. So basically, all the normal building blocks you need for a modern communication system. So how does it work? Very quickly, let me just change to here. And here's the front page of Matrix.org, and it's got this little animation at the bottom that hopefully will make a lot of sense. But if you have 3 servers, and each one has a bunch of clients off it, but here we were just showing Alice on alice.com, Bob on bob.com, and Charlie on charlie.com. If Alice sends a message, it is just an HTTP put of that message to Alice's server. It then fans out, or gets stored in that server, and it gets signed by that server. We're not showing any end-to-end encryption here. Then it gets pushed out to the other 2, bit more of a complicated HTTP post in this instance. And by the way, HTTP is just the baseline transport here. Normally, half the room have already left at this point because they don't like HTTP, or why are you using HTTP and JSON? The reality is that it's just the lowest common denominator simple thing. If you want to do CoAP, if you want to do MQTT, if you want to invent your own quick style whatever protocol, please do, and that's fine. But it's just the HTTP one that we mandate that everyone has to speak. That gets signed in those servers. They do an HTTP GET to get it, and you've got the kind of basics there that Alice has sent a message to Bob and Charlie. Now, if Bob responds, more interesting things happen. That message gets built into this directed acyclic graph, this tree of messages within that room. And if, say, Charlie responds at the same time, we have a race between Bob and Charlie. Now, this is kind of interesting because right now, the state of Alice's server is inconsistent with Bob, is inconsistent with Charlie. However, this is okay. It's a feature. It's an eventually consistent database, effectively. And so all that happens is that Bob's message is pushed out to Charlie, at which point the graph bifurcates to show there was a race between message 2 and 3. And likewise, message 2 from message 3 from charlie.com gets pushed out to the other 2, and they bifurcate too. at which point we were in sync again. So this is the whole point of Matrix. You've got a whole bunch of servers building up this data structure for the room, which can be a very bushy or very linear graph, and going and pushing and pulling, just like Git, just like merging conflicts in a Git tree between the different nodes. Later on, Alice might send another message, and it will go and merge the graph back together, and that gets pushed out to the others, and hey presto, everybody's in sync. So that's how Matrix works. So, clients. Well, we've got at least 40 of them out there now. They range from WeChat on text UIs. There's an Emacs-based client written by Ryan Ricks, which is really, really cool. You've got desktop apps like Quaternion, which is a QML and Qt app. You've got NAChat. In fact, let's just switch to NAChat quickly. I've got it open here. Here is the Matrix FOSDEM room on NAChat. Looks a bit like XChat. You've got Matrix HQ here. This is a room with like 6,000 people in it. It's the main one. I can say, hi, everyone. And meanwhile, if I go to another client like Riot here, you can see Coffee saying, hi, FOSDEM. I'll say, hi, Coffee. And you can see Evil Matthew, which is my test user because he wears a suit and is evil, saying, hi, everybody. Tolov saying, hello, and I can go, hello, from here. And because it supports Markdown, I can also yell back. We can go and say, upload an image into here. There's an embarrassing photo of us doing the release yesterday from the stand. And go and click on it. And you get the idea that basically Riot here looks a lot like Slack or some kind of Gitter-style tool, except everything is backed by Matrix. And also, you might notice there are these read receipts jumping down the right-hand side, doing this fun Tetris animation. Where is Slack's read receipts? Can anybody tell me where Slack's... Oh, wait, it doesn't have any. Anyway, so you get the idea of what we're doing there. We've got 6,000 people in this room. It's spread over about 500 different servers. So Eric here is at EricJ on jki.re. You've got, I don't know who else is on their own server. This guy on riot.reticule.li. Ardaxi is on ardaxi.com. And each of these servers have complete control over this room. It's so fun. On this account, which account am I on here? This is my Evil Matthew one. So I'm only in about 100 different rooms here. If I alt-tab to my real one here, then I'm in actually about 1,000 rooms. So I've got 415 direct messages open with different people there, 400 different rooms, and some of them are IRC-based, some of them are Slack, some of them are hybrid, and a fun example might be something like the Decentralized Web Summit room, which is split between Slack and between Matrix. And about half of the people are on Slack, half of them are on Matrix. Or I might go to IPFS, which is largely IRC, and lots of the chat going on here is IRC. But then you've also got a whole bunch of people at the top who are natively using it through Matrix. Make sense? I'll just quickly show something else, which is the video calling as an example of the WebRTC signaling. So in fact, if I go and take one of these messages, like that one, and I say view source on it, then, in my Dart theme, it's not very legible probably, but you can kind of see that we've got the emoji as the body of the message and some JSON and the message type. And what goes in these brackets can be anything you like. So we specify instant messaging and VoIP, but it could be literally GPS coordinates, thermometer data, car telemetry, whatever. So let's see what else I can do. So what I was going to do was to go and call my test user from Riot on iOS. So Riot as an app is a React app here. It's also an iOS native app. It's also an Android native app. It's also on F-Droid without any Google dependencies, if you so desire, which probably makes sense for FOSDEM. I'm not going to screen share my phone, but I'm going to go and tell it to do a video call through to Evil Matthew, which will hopefully, like all the best live demos, work perfectly. Come on. It does assume that I have internet connectivity on my phone, of course. Oh, there we go. So I got an incoming video call here from Matthew. I probably should accept it. And this is now using WebRTC here on, let me go full screen. It's only a video call. But, so this is using the Google WebRTC, obviously, on Chrome here. It also works on Firefox. And meanwhile, on this side, it's also using the Google WebRTC stack. Oh, hello, everybody. You can wave to yourselves now. Oh, if I unlock my screen, we might even show you that it does correct orientation support. Yay, there we go. Wave to yourselves. You look beautiful, everybody. Yeah, this is using the Google stack, but it also supports other stacks as well, and we might have some interesting news about adding new stacks into that in future. Anyway, that's basically Matrix as it looks from there, and if we go back to NAChat, you'll see that the conversation's been going on in there, hopefully. Meanwhile, on IRC, we've got the same thing happening here on Hash Matrix, and it's literally the same conversation. Reality Gap saying, great talk so far, thanks Reality Gaps. Meanwhile, on Slack, you would have the same thing going on here. So let's scroll down to the bottom of Slack, and you've got wherever it was. I hope we're in the right place. Come on, Slack. Don't know why that has... Oh, yeah, there we go. Reality Gap saying, great talk so far. A new bridge contributed by the community from Simon, if he's in the room somewhere. Oh, hello. Thank you for writing this. This is really cool. So this is my Telegram account, and meanwhile on Matrix HQ, you've got a pretty, you've got a whole bridge going through into Telegram. At the moment, this one is using bots to bridge people over, but we do also have one that logs in as your actual Telegram account as you, so that you can transparently bridge your Telegram persona into Matrix. And we're really in the point of building lots and lots of these bridges right now. So I think that's probably the obvious things to show you about Matrix itself. Obviously, lots of SDKs. Actually, a final cool one would have been Matrix IRCD. This exposes all of Matrix as an IRCD. So you can take your existing XChat or SSI or whatever it is and connect to port 6667 on Matrix IRCD that then proxies it into the entirety of Matrix. So you expose the whole thing as a IRC network, and you can do silly things, obviously, like talk IRC to a Matrix server, which then goes into an IRC bridge, and use Matrix as one great big, silly, over-engineered IRC bouncer. Home servers, we've kind of already talked about these. Synapse is about, in fact, we measured it earlier, it's now at 66,000 lines of Python and Twisted. We've hit some fairly major performance and maintainability challenges, specifically on typing, also the ability to do back traces and profiling over deferred inline callbacks in Twisted. And so all of our work is going now into Dendrite, which is coming along well, as I mentioned, and it's built around these Kafka-esque append-only event logs. Finally, you've got Rumor on the Rust side, and you also have projects like Bullet Time in Go, Pallium in Go, JSON apps in Java, which are basically experiments from the community. Bridges, well, we've already looked at a bunch of them. We're also Rocket Chat and Mattermost ones. We have VoIP ones to FreeSwitch, Asterisk. Really fun one. If anybody likes libpurple, please can you come and talk to me about taking over usage on the libpurple bridge. Because this one should be the coolest in that it can talk anything libpurple can and expose it into Matrix. So when I built it, we did it with Skype, and it worked pretty well. And you could use this to bridge into WhatsApp or Facebook or whatever. So if you like hacking on libpurple, please come and talk to me. Meanwhile, on the community, we've had iMessage recently, Twitter, Facebook Messenger, blah, 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 blah. You get the idea. And everybody seems to love writing IRC bridges, so we've got about 8 of them. We've already shown you what it looks like. Community status is that we started in September 2 years ago now, or just over 2 years. Very late beta. Bits of it are out of beta, some of it isn't. We've got 700,000 accounts on the Matrix.org server, and we're pushing about 700,000 messages a day. Actually receiving them today. We realized that all of our message rates actually have been miscalculated, and that we'd only ever looked at the messages coming in, which is about 10 a second. But in terms of going out, we're actually pushing about 1,000 a second on the server. We've got 70,000 rooms on Matrix.org, but a really important stat is this one, the 1,500 federated servers out there, which are run by you guys, and the more the merrier. And in fact, almost half of the traffic on Matrix currently is not on the Matrix.org server, but it's actually out there in the wild, in the wider ecosystem. So it's pretty centralized to Matrix.org right now, but honestly, I'd like to get to the point where we can turn off the main server and everybody can run their own. In terms of the user growth, that's how we've got to the 700,000 users so far. You can see that we really took the kind of training wheels off it at that point. But a better graph rather than total users is the total messages a day. And this is looking just at the unbridged messages per day. So this is ignoring all of the traffic to and from Freenode and MozillaNet and Slack, etc. This is native Matrix traffic. And you can see that we're up at about 100,000 messages a day, so it's not huge, but critically the acceleration is frankly petrifying in terms of the uptake we have there, and that's where a lot of work has gone into optimizing Synapse and making it good enough until we can get Dendrite running so we can really, really go fast. Now let's talk about crypto. Who wants to hear about crypto? Yay! Woo! So this is an Olm. It's a salamander from the cave systems of Postojna Jama in Slovenia. And it's the closest thing we have to a European axolotl, which is the North American salamander that Open Whisper Systems named their ratchets that they use for cryptography after originally in Signal, which was text secure, before they renamed it the very boring double ratchet. Well, they renamed it double ratchet. We're calling Olm Olm, and Olm is our own implementation, and it's the foundation of all of the encryption in Matrix. As I said at the beginning, without end-to-end encryption, well, let me just kill Telegram so it stops bouncing at you. Matrix's replication conversation history is a huge privacy problem, to put it mildly, because in a room like Matrix HQ, if we turned on crypto, it's going to have the plain text over 500 different servers. So we've spent 2 years gradually working away at putting end-to-end crypto into the absolute heart of Matrix. And the point, the goals we had here was to trade off privacy and usability, so that was the question at the beginning. So sometimes you do want perfect forward secrecy, and sometimes you really want to be able to add new devices and invite people into a room and be able to replay, and we want to do both. And I think we're basically unique in wanting that, because everybody else, whether it's Wire or Signal, are really going for the hardcore sort of secrecy approach. We decided that we were going to encrypt and trust things per device rather than per user. So this is a big deal, that when you send a message in Matrix to somebody that's encrypted, you are specifying the devices which receive it. So I'm not sending it to a person and trusting them to go and blindly sync it to a whole bunch of different devices. I have the ability to blacklist particular devices from receiving messages and validate particular ones.
What if I don't want to expose my device?
Well, if you don't want to expose the devices, then rename them to my device or something ambiguous. At the moment, we necessarily have to expose the number of devices you have, but otherwise you wouldn't be able to encrypt for the devices. So at the moment, there's a bit of controversy that we name the devices based on something vaguely useful and expect for you to anonymize it if you want it to be anonymized. In future, we're going to default to prompting the user so that if they want to remove any identifying data, like the model of their phone or the URL of their client, they can do that. We wanted to support big rooms. A lot of people give up on this because A, it's really hard, and B, if you're encrypting for 10,000 devices, why bother? Because one of them's going to get owned, and so the trusted compute surface is going to be very big. But in practice, it's a common use case anyway. In a big company, or even a big gathering like this, which I guess is basically public, or it is public, you might still want to at least attempt to encrypt the contents there. And as you've seen, our Matrix rooms are huge, and we want to support them. So if somebody turns encryption on Matrix HQ today, we don't want the whole thing to explode. We want to encrypt non-public rooms by default, but we haven't yet whilst we're in beta, but that's the goal. Obviously, there's no point in encrypting a conversation like this one, which you want to have on the public record. In fact, the encryption gets in the way. And finally, we want it to be available to everybody in Matrix. So, high-level, 10,000-foot overview. We've got two different mechanisms at work here. We've got Olm itself, a little salamander, which is a double ratchet implementation. It is almost identical in functionality to the one that Signal and Facebook and LO and all the other axolotl double ratchet implementations use. However, we use it completely differently. What we do is to use it to establish a secure channel between two devices, and then we just use it to synchronize the key data that's required for Megolm, which is the new ratchet, the main ratchet that we use for encrypting to a group of receivers. So the deal is that if I want to send all of you guys a message, I will go and, first of all, have to set up a one-to-one channel with everybody, but I only have to do this once in order to share the group ratchet state, which I then use to encrypt my messages to the room. So whilst it's pretty nasty that I'm going to have to do like 800 one-to-ones at the beginning, and honestly that does take a time, and people using this today can see a good 10-second delay whilst it does the initial setup. Once it's in place, I can then use the Megolm ratchet to generate a series of keys for the members of the room, for the messages which I'm sending into the room, and hopefully everybody else has the same ratchet so they can decrypt. Easy. Sorry? So when somebody joins a room is the question there. And this is where it becomes not easy. And there's a whole bunch of slides on the whole problem of what do you do when somebody adds a device into a room. Because it's not a person joining a room. They could just be adding a new device in. And, well, how about I just show you? So let's go back to Riot. And this is the right one. I'll go into our big test room, which is called Megon Test. This one has got 127 users in it right now. And I haven't actually validated any of their identities. You can see it's working pretty well. I can go and receive all of these messages. If I scroll back far enough, you'll probably see some of the bugs which we've been chasing in the last couple of months. But so far, it's just fairly inane test chat. Oh, ironically, it's working perfectly now. Great. Things never break when you want them to. And oh, there's the Megon test, which is working there. Now, if I went and send a message in here, brilliant example. So, room contains unknown devices. So since I last sent a message in here, somebody's added a device, which makes sense because there are over 1,000 devices in the room. And so I get this dialog popping up saying, "Uh-oh, this room contains unknown devices, have not been verified, no guarantee that they actually belong to the users. You might want to go and verify them." So I've got one from Simon there, I've got one from myself, where I've logged in an incognito tab. And you can see the names of the devices here are the URLs and the browsers and the OSs being used. So one of the things we're missing now is a good UX for verification. So if I say, "Oh, hang on a second, I wonder whether that is Simon," if only he was in the room and I could ask him in person to compare his public fingerprint keys. Now at the moment, depressingly, if I hit the verify button, that's precisely what happens. We do have this disclaimer at the bottom saying, in future, this will be much more sophisticated, but right now, I would say, "Hey, Simon, you know your device, PSIHDDLQEP, don't suppose the public key fingerprint is capital O, capital M, capital U," and so on and so forth. Obviously, we should be doing this with a mnemonic, we should be using a QR code, we should be hashing it down to a smaller amount or whatever. We just haven't done it yet. This dialogue itself is only, well, at least this dialogue, the one we were on before, is relatively new as of yesterday. So that gives you an idea of where we are in the rollout. On the other hand, if the verification failed, and hang on, that you didn't add that device at all, then the lovely thing I can do is literally just hit the blacklist, not that hard, hit the blacklist button, at which point, when this is now telling my client never to set up a one-to-one session with his device, and that device will never receive the message. And you can do this on a per-room basis, which is kind of fun, because it finally solves the problem that if you're talking to somebody and they have an iPhone and an iPad and public PC they left logged in at a cyber cafe, even if they're an idiot with their information security, you have the option to say, "Hang on, I just want to send this to their phone," or "I just want to send it to the iPad on the sofa that the kids can see," or whatever it might happen to be. So let me unblacklist them. Yes. Oh, yeah. So if I then go and look at Simon here in the members list, I can see the same list of devices that he has here, and I can literally just go through saying, "I never want to talk to you ever again." But luckily, at the moment, this is just personal data, and in fact, it's even done on a per-device basis, which is something we're struggling a bit with, because obviously you can have some interesting security issues if you trust a server to be synchronizing the blacklist information. So at the moment, we're just doing it per device. And if we actually look at the messages, and also critically, it queued my message here. So even after all that, it needs to be damn sure that this is actually the message that I want to send to the room. So it's this chance that I can hit cancel, or I can hit send. And if I hit send, then it will go through setting up new sessions with everybody and send it out. I'll cancel it for now, but let's look at Reality Gaps 1. The decrypted source is not very exciting. It's literally just going to be Megon test from Janssen. But if we look at the original stuff, it's this beautiful thing which has just got the public key of the device he was sending from. We've got the ciphertext, which is base64, AES encoded chunk of the JSON keyed with the ratchet state that matches the session ID, which is the public key of his particular ratchet that he's sending to me. So basically it's there, and it works, and it scales up. Let's go back to the slides and see where we go from here. So we're using elliptic curve 25519 keys. key pairs get generated at login time. Obviously, the private ones get stored on the device, duh. This is a bit of a problem on the web, where there isn't a good place to store your keys. So at the moment, we store them on local storage, which is obviously not ideal, because somebody can do an XSS attack. Another question?
Where is the history stored? Can I access the history offline, or is it on a server?
Yeah, so if you're joining a room, and so the question there was, can you access history offline? And yes, you can absolutely access it offline. And at the moment, Riot does stuff offline if it loaded it from the server when it was online, but we're just changing it to store it properly on locally using IndexedDB. And you store all of the session keys in your local storage so that you can then re-decrypt afterwards. And if you add a new device into the room, at the moment you have to export the keys and import them onto the new device, but in the relatively near future, you'll also be able to automatically share the keys over. Another quick question?
Yeah. Given storage considerations, like how long are you keeping these messages on a node? Because, I mean, you'll run out considering there's like 80,000 messages.
So the question is, how long do we persist messages on the Matrix nodes? And the answer is, it's up to the guy who runs the node. If I'm running my home server on a Raspberry Pi or on my phone, I might keep a couple of tens of megabytes of messages. If you're running Matrix.org, we're currently up to 750 gigabytes of messages. And you can throw away old history, and that's okay, because it will just get backfilled and resynchronized if you try to scroll back far enough. So as long as one of the servers for one of the participants in the room has the old history, you're fine. So going back to the key management, public keys are published on your home server, verified by comparing public fingerprints, as we just showed, with big bold text here saying this is placeholder UX. Attachments took a lot of work because decrypting them client-side with the correct security policy is a nightmare, but we got it to work. They're using AES-CTR, but with an integrity hash, and they get a new key for every attachment that's sent. Ohm itself, we kind of already talked about it. It sits on matrix.org/git/ohm. We have a formal spec for it, which is very important. For ages, the official double ratchet from Open Whisper Systems didn't have an official spec, although they have a really good one now. And this is used for one-to-one communication. We chose it because it's the industry standard now, and we wanted to avoid ruling out compatibility in future with WhatsApp. And a ratchet obviously generates a non-reversible series of keys for encrypting stuff. And back in February of last year, literally this time last year, we were encrypting each message per recipient. So it's an O(n)² problem, and there was no way to share history. It worked, it was a good proof of concept, but it sucked. I mean, it's how iMessage does it today still, and it's how many other group messengers try to do it, and it just doesn't scale beyond 5, 10 devices. There's a picture of a double ratchet, which we don't have time to go through. Megon, however, as I said, totally new ratchet. Again, it has a formal spec up on the Matrix spec. And we go and maintain a session per sender for each recipient called an outbound session. And the big novelty, actually, from the cryptography on Megon is that you can fast forward existing ratchets before you share them. So if I want to seal the history of the room, I can throw away my ratchets and start over again. I can go and reset up one-to-ones with everybody in the room, and then I can start encrypting over that. However, that's going to take ages, and it's a bit inefficient, and if you do it all the time, we're just going to be doing nothing but key exchange. So a fun thing you can do is that if a new device or a new person joins the room, you can take the current one and fast forward it rapidly so they can join at the right point in time, and they can't go backwards. That shouldn't be there, so ignore that. Libohm's architecture diagram is basically this. You've got crypto primitives using AES, SHA-256, Curve25519. You've got ratchets, you've got session management, account keys, then you've got the Megon ratchet, and then you have a C API over the top. It's about 100K of 64-bit 8086, and it's about 200K of ASM.js. And we transpile it via Encrypting even into JavaScript using it on the web devices. And we use it natively on iOS and via JNI on Android. Security assessment. So this is a big thing, that we went and got Libohm, the library itself with the ratchets, assessed by NCC Group in September of last year. And this is critical because we've done the schoolboy error of implementing our own crypto. So it was absolutely critical that we had a proper professional independent audit. We even got it released to the public unlike many of the other ones out there. And so if you're interested in seeing all of the interesting problems that we had and all the things they found, I do recommend going and reading the NCC group public assessment of LibOlm. At the Olm level, there were 2 low-risk and 1 informational findings, which was pretty good. MegOlm, predictably, was a bit more controversial, with 1 high, which is an unknown key share attack, 1 medium, and 4 low-risk. An interesting problem we had is that 3 of the findings they found, though, were actually features, in that they said, hang on a minute, you can use this to break PFS, this isn't PFS. And we said, well, yeah, one of the cool things about it is that if you want to turn off PFS, you can. They said, well, technically, that's a vulnerability. So 3 of the issues are vulnerabilities of that form. We fixed everything, obviously, and since the audit, we haven't found any more issues. So that was a really, really fun thing, and I highly recommend working with NCC Group if you want to do something like that for your own crypto. We've already demoed it. However, we've had a couple of problems along the way. The big one is that we spent ages obsessing about the Ratchet implementation and getting it audited and making sure it didn't suck. And if anything, we probably focused too much. Because it turns out that the problem of what happens when a device joins a room and all of the reliable and efficient synchronizing of the MegOlm state over a federated system, particularly like Matrix, is really non-trivial. And it turns out that it's about 2 or 3 times more code than the actual Ratchet, and in some ways it's a lot more fiddly in order to actually get things secure and right. So you have to know precisely what devices are in the room. You need to ensure that your Ratchet has been shared with them, and it turns out the scope for races here is just spectacular. I mean, even that sentence itself here is basically racy in terms of at what point you decide whether what devices are in a room, and you send a message, and meanwhile some guy goes and adds a new device in whilst you're sending it, and they're never going to get the state, and they're never going to be able to decrypt it, and they're going to send you hate mail saying, oh, I can't decrypt that message. So honestly, the last 2 or 3 months have been chasing around these, and it's one of the nastiest bugs I've ever seen, because the symptoms are always the same. Somebody can't decrypt a message, and it says unknown inbound session ID. And so we get bug reports at a rate of about every half an hour with somebody saying, oh, I got the bug. Of course, there are about 20 different races of different incarnations and flavors that can result in that state not being shared correctly. On the plus side, we've hopefully identified them all, and we've almost fixed all of them. We did a release yesterday, which we hoped would finish up the remaining ones, and predictably enough, we got we got a key share fail. But we're very, very close to wrapping it up, at which point we'll get it audited, and it will be out of beta. Another interesting problem here is that we went and coupled the implementation to the client SDK, because necessarily the key exchange stuff is talking to your server to say, hey, here are my keys, and what keys are there for the devices in the room. And this was a bit of a disaster because we implemented it in the client-side code, which means that you have 3 completely separate implementations on JavaScript, Objective-C, and Java for precisely the same logic. So not only do we have some of these nasty architectural race problems to deal with, we're also constantly porting the bug fixes between the 3 platforms. So there's definitely some kind of learning there. And I'm not entirely sure what it is, because we could push it into a native library, like the Ratchet itself, but then we're going to have to expose all of these different APIs back and forth to talk to the server. And I'm not convinced that's going to be any nicer than having to implement it 3 different times. Who knows? Design problems. We also have an interesting nagging concern that MegOlm may be over-engineered, in that you end up generating a lot of these session keys, and critically, if you want to do the offline replay, or if you want to share it with new people, that means you have to keep all of these key sessions. So it's not a key per message, it's a key per n messages or per session, but still I'm up to about 3 megabytes of key data in my local storage now on my Chrome, and that's over a couple of months, which doesn't feel very scalable. Plus, that's in local storage, and you have a limit of only 10, 20 megabytes on local storage anyway. So it's feeling a little bit unwieldy there. They were talking about, do we put them on the server? But that also feels a bit dodge, that you're taking key data for end-to-end encryption, putting a passphrase on it, and then putting it back on the server. I mean, it kind of works, but again, we need to think a lot more about that. There's also the question of whether the funky fast-forwarding is actually worthwhile, because we have so many sessions anyway, why not just go and create another one when I want to invite somebody to a room? Basically, where we're at right now is to see how well it works and tune how often we create new sessions, and then perhaps we might go back and redesign it a bit. And obviously, at the matrix layer, it's pluggable, so you can keep evolving the ratchet and the algorithm as required. So in terms of our goals, can we do trade-off between privacy and usability? Yes, we can in the protocol, but we haven't exposed that in the clients yet. We can do the encryption per device. We can do big rooms. We will encrypt non-public rooms by default once we're out of beta, and we will be supporting on all Matrix clients. And the way we're thinking of doing that is to actually write an end-to-end proxy. So if you have one of the other random clients out there, and you don't want to spend a couple of months adding end-to-end encryption to it, you can just route it through a proxy that you run on localhost in order to go and turn it into the end-to-end. Finally, quickly, metadata privacy. Matrix does not protect metadata currently. So if you want to be private about who you talk to and when, ignoring the contents, but the metadata, then look at something like Ricochet or Vuvuzela. The reason for this is that protecting metadata is basically incompatible with bridging, and the entire architecture at the moment assumes that the servers can see the metadata. However, we have done a thought experiment for future, and hopefully somebody will help us build this, where if you run the home server client side and you tunnel the traffic over something like Tor, and you use anonymous store and forward servers like Pond, then you might be able to protect that metadata. And the kind of architecture looks like this, in that our blue home servers are now running on your green client, and the actual client app is the same. And this is really fun, because the client can be identical to what you have today. So this is still Riot, it's still WeChat, it's still NateChat, whatever, but it's just happening to talk to a home server that's running client-side. And then, if somebody wants to send a message, they would go and send it to a hidden service on Tor, which would act as a store and forward thing to send it out for another hidden service, at which point the metadata is going to be exposed only on the client, and in here is going to be a one great big nice blob of anonymity. It's sci-fi. If somebody wants to build one of those, please do. And latest release, the one that we released today, which was actually yesterday, not that I wrote this yesterday, gives a warning when you get unknown devices that we saw, ability to blacklist, backup and import is a big deal, and also RAID-shaped bug reporting, which will go and dump all of your JavaScript logs to us so we can work out why you got your unknown inbound session ID. Mobile apps are catching up soon. They're a bit more buggy, but the crypto's still there. And in practice, it works fine as long as you don't have lots of people joining and leaving. What's next on Ohm? We've kind of touched on it already. It's the ability to share actual data with new devices, cross-signing perhaps to ease verification, better verification full stop. Push notifications are a bit broken on end-to-end. We need better primitives and performance. We're not using web crypto yet. We're using Inscription compiled native primitives on JavaScript, which is a major security no-no. We obviously need to get it audited. We want to turn it on by default, and we want to have some kind of way of negotiating sensibly with clients that just can't speak it at all. On Matrix, threading, bridges, tagging, ACLs, file management, and then decentralized identity and spam, which is an increasing problem, which I gave a talk about this morning. Sorry if you didn't make it. It will be published, though, by FOSDEM, of course, with all the other ones. We need help. Really, we need help from everybody here. Please run your own servers. Please run gateways. Please write gateways. Tell us where it sucks. If you're writing a new app, please don't create yet another proprietary HTTP API for messaging. Go and consider using Matrix or XMPP or anything rather than reinventing the wheel. And please follow us on Twitter and tell your friends and family. Thank you very much. I think I have 1 minute for any more questions. Oh, no, I've got 10 minutes, apparently. Wow. Bonus. Oh, okay. So anybody got any other questions? We have a question.
Hi, very simple question. Thanks for the talk. It was great.
Sure.
Contact list management?
So the question there is contact lists as a thing. So
we have Pigeon and all that, you know.
Sorry?
As in Pigeon and all that, just
yeah.
seeing a list of your
a roster kind of thing. It's something that a lot of people feel is missing. We have it in the protocol. We have the concept of presence lists, which allow you to subscribe to the presence of other people. Literally none of the clients actually implement it, because in practice people haven't felt much of an urge for it. But It's something that we will probably add on the mobile versions of Riot where it makes more sense because you can steal the address book off the phone and use that as the roster.
Are the slides available?
Yes, I'll be publishing the slides. I'll put them into Matrix HQ in a few minutes, and we'll put them up on the blog in the near future. Any other questions? We have one there. Oh, and one there.
I've seen that in Dendrite, the new implementation, there is like a Kafka implementation so far. And is that a new dependency that we need Java to run a Matrix server in the future?
God, no. So the question there was, will Dendrite be dependent on Kafka? And the answer is absolutely not. We're using Kafka at the moment to prove the event bus, but all of the APIs and implementation deliberately call it Kafka-esque because in the simplest case, you would just use Go channels within Go itself in order to stitch it together. And if you don't want to use Kafka and you want to use a Go implementation of Kafka, then that's fine too. It's just very much a pluggable message bus module.
You mentioned server-side search feature. How is that compatible with end-to-end encryption?
So the question is on end-to-end search, on server-side search, what do you do about end-to-end? There are two options. You can do homomorphic encryption and try to search things on server-side despite it being encrypted, which we do not do. That's a whole different level of complexity. The other solution for search on end-to-end is that you just do it client-side. And so that's one of the reasons on Riot that we're ending up storing all of your history client-side, not only for offline support, but also so you can just spider it locally, just like you're grepping your IRC logs. And time is up, I'm afraid. Thank you very much, everybody.